Dear students, let us see the topic of balancing of rotating masses. Okay. Whenever certain mass is attached to a rotating shaft, it exerts some centrifugal force whose effect is to bend the shaft and to produce vibrations in it. In order to prevent the effect of centrifugal force, another mass is attached to the opposite side of the shaft at such a position so as to balance the effect of the centrifugal force of the first mass. This is done in such a way that centrifugal force of both the masses are made to be equal and opposite. The process of providing second mass in order to counteract the effect of the centrifugal force of the first mass is called as balancing of rotating masses. Okay, here we are providing extra mass to balance that earlier disturbing mass. Okay, both are in opposite and equal. Okay, both should be equal but opposite direction. Okay, here we have different types. Okay, those are balancing of single rotating mass by a single mass rotating in the same plane. The balancing of a single rotating mass by a single mass rotating in the same plane. The second one is a single rotating mass by two masses rotating in different planes. Third one, balancing of different masses rotating in the same plane. The fourth one, balancing of different masses rotating in different planes. Let us see one by one. Let us see the balancing of a single rotating mass by a single mass rotating in the same plane. Okay. See this figure. Okay. Here we are having mass M1. Okay. This is the disturbing mass, where M2 is the balancing mass. Okay. Consider a disturbing mass M1 attached to a shaft. Okay. Rotating at omega radians per second. Okay. Let R1 be the radius of rotation of the mass. Okay. As you know the centrifugal force formula. Okay. That is Fc equal to the basic formula. Fc is equal to m r omega. The basic formula is mr omega square. Okay, that means here for the first mass we are having formula m1 r1 omega square, mr omega square. This is the first one, fc1, m1 r1 omega square. Okay. Here the centrifugal force for this mass acts radially outwards, thus produce bending movement on the shaft. In order to counteract the effect of this force, a balancing mass M2 may be attached in the same plane of rotation of disturbing mass, such that centrifugal forces due to the two masses are equal but opposite. Okay. So let's take R2 is the radius of rotation of balancing mass M2. For this also we have formula M2 equal to, as I told earlier, M is equal to, that is FC2. FC2 is equal to FC2 The basic formula is m r omega square. This is for 2, so m2 r2 omega square. m2 r2 here. m2 r2 omega square. This is for balancing mass. Okay. But as you know, here both are same. So that is equal to these two centrifugal forces. M1 R1 omega square is equal to M2 R2 omega square. But here omega is the angular velocity. Is same in both the cases. So the remaining is M1 R1 is equal to M2 R2. Okay. Here the product M2 R2 may be split off in convenient way, but the radius of rotation of balancing mass M2 is generally made large in order to reduce the balancing mass M2. Okay. The product is never changes, but here a chance to reduce the balancing mass M2. So for that, R2 should be made larger, then M2 will be smaller value. Okay, so here you have to try to reduce the size of the balancing mass. For that, you can increase the radius. R. Important. Okay, this is about balancing a single rotating mass by a single mass rotating in the same plane. Okay, in exam they ask describe in detail about how to balance a single rotating mass, single plane with single mass. This is the answer. This is sufficient. Okay, let us see the next one. Balancing of a single rotating mass by two masses in different planes. Okay, see that. Here we have two cases. The case one is when the plane of disturbing mass lies in between the planes of the two balancing masses. See here M1 and M2 are the two balancing masses. Where M is the disturbing mass. Okay, let us see one by one. That where L1 is the distance between the planes A and L. Here we have three planes L, M. This is the plane A. Okay, so where L1 is the distance between planes A and L. A and L. And L2 is the distance between the planes A and M. A and M. And where L is the distance between planes L and M. L and M. That is the outer layer. Okay. As told earlier, for the first mass along the plane A, centrifugal force for the mass M in plane A, that is Fc is equal to mr omega square. Similarly, in plane L for mass M1, we have formula M1 Fc1 is equal to mr omega square, that is M1 R1 omega square. Similarly, for mass M2 in plane M, that is M2 R2 omega square. Okay, these are the forces. So based on this, here these two are in downward direction, one direction, and this is in one direction. So from that we can write Fc equal to Fc1 plus Fc2. From that, mr omega square is equal to M1 R1 omega square plus M2 R2 omega square. Okay, here as I told earlier, here omega is constant. So you can write as simplified form, that is mr is equal to M1 R1 plus M2 R2. Okay. Now, in order to find the magnitude of balancing force in plane L, okay, take moments about P. Take moments about P. Okay. which is the point of intersection. See, let us see. A taking about P. Then FC1. See here. FC1 means mass M1. We are taking about point P. So this is L into here. This L into the force here is FC1 is equal to FC. That means for mass M, FC into distance L2. Okay, this is the formula. Okay, from this you can write M1 R1 omega square into L is equal to MR omega square into L2. Okay, from that omega is constant. So M1 R1 L is equal to MR L2. I want M1 R1, then you can write MR L2 by L. Okay. Similarly, in order to find the balancing force in plane M, okay, now take moments about Q. Then we can write FC2 means in plane M for mass M2. FC2 here. FC2 into total distance L. FC2 into L equal to FC for mass M. FC into L1. Okay, we are taken from point Q. FC into distance L1. Again, here also you can write FC2 means M2 omega square R2 into L is equal to MR omega square into L1. Okay, then M2 R2 L is equal to MR L1. I want M2 R2, then you get MR by L1 by L. Okay, this is the case 1. Let us see the next case. Second case. When the plane of the disturbing mass lies on one end of the planes of the balancing mass, which is in one end. Earlier, balancing mass are in at a opposite end, but here the plane of disturbing mass lies on one end of the planes of the balancing masses. Okay. Here, M1, M2 are the balancing masses. Where M is the disturbing mass. Okay, this is one balancing mass inside of the disturbing mass. Okay. So here, based on this figure, okay, here for M mass we have FC. For M2 we have FC2. So these two are in one side, and M1 means FC1 in opposite. That means where FC is equal to MR omega square, FC2 means M2 R2 omega square, FC1 M1 R1 omega square. As you know, omega is constant. MR plus M2 R2 is equal to M1 R1. Similar to earlier case, here also let us take moments about P. Okay, that is for mass M1, distance is L. So FC1 into L about P. Okay, and for mass M2, sorry, mass M, that means FC. For mass M, FC into total distance L2 from P. C into L2. From this you can write FC1 means M1 R1 omega square into L, and FC means MR omega square into L2. Here omega constant, so M1 R1 L is equal to MR L2. Then M1 R1 is equal to MR L2 by L. Similarly, take moments about to Q. Then FC2 into here, FC2 into L. That means for mass M2 we have FC2, total distance L is equal to FC. That means for mass M, FC into L1 is FC into L1. Here we are taking the about point Q. So that's why C2 into this L, and here FC into L1. Then get for FC2 M2 R2 omega square into L. For FC MR omega square into L1. Okay, then you can write M2 R2 L is equal to MR L1. I want M2 R2, so MR L1 by L. Okay, like that you have to balance. This is about balancing a single disturbing mass with two different masses. In case one, okay, lies in between the planes of two balancing masses, middle but opposite direction. But here, in lies on one end of the balancing mass. This is how you have to balance the one mass, disturbing mass with two masses. Okay, one disturbing mass with two balancing masses. Exams they may ask, explain how to balance a single rotating mass with two masses in different planes. You have to write these answers. Case 1, case 2 you have to write. Okay, thank you.